It's a good bell work. Good 5 questions there. Should have those done though. From everything in terms of pi. So I mean, if you calculated this with an estimation, then you may have come with the decimal answers. But that's not what this said. It said leave everything in terms of pi. So it wants pi in the answer. So like the circumference, you take the diameter and times it by pi, 20 pi. Or this one, it wants the area of a circle with diameter 20. So you cut that in half to make it 10. That's the radius. 10 meters, 10 times 10 is 100. 100 times pi. That calculation would give you the estimated answer for the area of that circle, and then so forth with these other 3. So here's our objective though. I can find the surface area of composite figures. Take 30 seconds and copy that down. By the way, this is not actually something that's new. It's just that now instead of looking at just a regular shape like, I don't know, like a cylinder like this, now it's going to be like a cylinder that's attached to the top of a prism like this one. Okay. And then we're going to say, hey, find the surface area of this figure. Boom. Not too bad. So yeah, composite figures just means that composite just indicates that you're pushing or putting 2 shapes together, 2 figures, like a cylinder and a prism. It could be a cone and a prism. It could be a cone and a cylinder. Who knows? I think a common one, of course, would be a cone and then a half sphere. I'm thinking specifically of ice cream, but I think of ice cream probably more than I should anyways. All right, finding surface area of spheres. This is the formula for the surface area of a sphere. 4 times pi times the radius times the radius. You can say radius to the power of 2. So that's really the only measurement you need on a sphere is the radius in order to find its surface area. It's also the only measurement you would need if you're finding the volume of the sphere, although we're not going over that today. All right, so it says draw a net for the composite shape below. I'm not going to do that. But I am going to find the surface area. We're down to 2 decimal places if it's needed, although it may not be needed because of these. We're not really using pi in this case, but we could. Let's find out. All right. Now, what I would notice on this shape right here is that what we have is a prism, and on top of that prism is another prism. This is a rectangular prism here on the bottom, and on top is a triangular prism. On the front, I have a triangle. The back is a triangle. The rest of the sides or faces are rectangles. And on the bottom, we got the rectangle on the bottom and top, and then rectangles all the way around it. Okay? So really, what I would be looking at, although you could say this is, 1, 2, 3, 4, 5, 6, 7 faces, I'm going to split these 7 faces up into 9 faces. Okay? Look at the bottom rectangular prism. I'm looking at 5 faces. You say, well, a rectangular prism though has 6 faces. That's true, but the top face is covered with this prism. So it's not considered part of the surface area. Okay, so it needs to be on the surface in order to be included in the calculation for the area. So I'm going to just split these up, and I don't have enough colors to just kind of, well, separate all of these, but it doesn't really matter where you start either, okay? So what I see here is I would start with this triangle right up and down. Although you could start with the rectangles. I'm just starting with kind of the different shape amongst all these other shapes. That's this triangle right here. And I see that it has a height. So for my triangle, the area for the triangle, I have a height of 0.7 meters. And the base length there, this one, that's this 1.8 meters right there, okay? So 0.7 times 1.8, but I do need to divide this by 2 because it is a triangle. So the area of one of those triangles, 0.7 times 1.8 divided by 2, now I get 0.63. And some of you say, well, we got this other triangle that matches it on the back. That's true, so I am going to end up multiplying it by 2 anyway, so 6.3 times 2, and that's the area of both triangles, which is 1.26, and this is in square meters so far. So that's 2 of the faces out of the 9 that I need to find. Next up, and this may sound worse than it is because looky here, this triangle right here on the kind of the top right of this triangular prism. It actually matches this one that's on the top left of that triangular prism as well. So I can take that and multiply it by 2 as well. So I'm looking at this, it's a rectangle, right, because it's a prism. And that rectangle, this length right here shows it's at 1.1 meters. And then this length right here is showing at 1.14 meters. Okay, so again, I do want the area of that rectangle, which is 1.1 times 1.14, which in my calculator, let's see, 1.1 times 1.14 gives me 1.254, and again, that's in square meters. But again, it matches this one on the back side right here, so that's going to multiply by 2, which gives us the total area. Looks like I need this space down here. There we go. The total area of both of those rectangles is going to be 2.508. Again, that's in square meters, okay? So I'm going to highlight these just so I don't lose track of them, because we're going to have to add all these together in the end. Yeah, so that's a good question, and it's important to notice, yeah, that while I've covered these with my drawing, you know, if you got the original drawing in front of you, then you can see that these values are pointing to each other, which duplicates the purple triangle here, or rectangle, with this other purple one. All right, so what are we at? 4 sides, 4 of the surfaces right now out of what should be 9. But I've taken care of all the surfaces that are on the surface for that triangular prism. So I need to move on then to the rectangular prism. And what the heck, I'll start with this, this edge, the left surface right there, which actually matches this right surface right there as well, okay? So I'll keep that in mind after I calculate the area of one of these rectangles. So one of those rectangles, we can see that the bottom length there is 1.1 meters, and the height right here, 0.8 meters. So the area of this one can be 1.1 times 0.8, which, let's see, let me do it in my calculator just because I'm prone to make mistakes on these types. So I got 0.88, and that's the area of one of those rectangles, but again, there's 2 of them, right? So multiply that by 2. So multiply by 2, and we get 1.76. So that's the total surface area for both of those rectangles. Again, I'm going to kind of highlight that so I understand where that is. So we got 3 more faces to go. Let's see what we can do here. I'll start with this front face right here. I'll do it in orange, which again matches the back face here. And this rectangle is showing as a 1.8 meter. That's this one. And the height of there is 0.8 again in meters. So if I want the area of that rectangle, I take 1.8 times 0.8. And let's see what that gives us in the calculator. 1.8 times 0.8 is 1.44. And again, that'd be square meters, but I got 2 of these rectangles. So I'm going to multiply that by 2 to get 2.88. So that's the total surface area of both of those rectangles in orange right there, 2.88. Well, our final rectangle is just here at the bottom. And we see that's a 1.8 by 1.1 meter rectangle. So let's see if we can draw that over here. Well, I had it. 1.8 meters here. And 1.1 meters there. Okay, so the area of that one, and there's only one of these, by the way. 1.8 times 1.1. Hopefully you've even been able to organize your work better than I have. 1.8 times 1.1 in my calculator. And yes, I ran out of space there, but I got 1.98 in meters. So I'm gonna highlight that there at the bottom. So what do we got to do now? Well, what we're gonna need to do is calculate the full surface area. So I'm gonna start with the values I start with. I got the red one, right, at 1.26 square meters. That's the two triangles. And then I think we did the purple ones, which totaled 2.508, and that was two rectangles together. And then we did the green rectangles at 1.76. And then the orange, which was 2.88, those two rectangles. And then the final rectangle, just one rectangle, 1.98. And yeah, we do need to add all these together to figure out our total surface area for the shape. All right, let's see if I can do this in the calculator correct this time. And then we'll see if it matches yours. 1.26, 2.508, plus 1.76, plus 2.88. I did 7.16 in my calculation, which was incorrect, of course. And this is what I get then. That's a good lesson in that right there is, you know, when you're typing this in the calculator, make sure that you typed it in correct. I should have known. I mean, 15 seems like it was too high anyway. So, and now we can round though. So the 8 in the hundreds place value, because this is where it wanted, and then this 8 adds 1 there to our designated place value. So that ends up being 10.39. But again, the label for this one is in square meters because we are looking at surface area on this one. So 10.39 square meters would be our final answer for this. So again, we're looking at a rectangular prism attached to a triangular prism again. So everything's going to work pretty much the same. This one may look like we don't have enough information to solve it, but we do. And here's why, okay? So this length right here is 12 inches, which means this one is also 12 inches. But it's saying this full length right here is 24 inches, okay? Which means that if I wanted to solve for this length right here, we'd have to take the full length at 24 and then subtract the partial length at 12, which means that purple length is also at 12 inches, okay? So it's going to be important to know that value, not only for the triangle, but then that rectangle on the bottom as well, all right? Now, it doesn't matter where you start on these problems, but for me, I am going to start with the triangle right here. I'll do it in red. And yes, it does match this triangle here on the back side as well. All right? So I know in the end that I will have 2 of those. But you may say, well, how tall is this thing? It's not showing you the right angle, which is kind of jacked up, but there is one right there. Okay? Now, why do we need that right angle? Because that tells us the height and the base value of this triangle. So if I wanted the area of this triangle, what we're looking at is a right triangle right here. With the right angle, the height is 12 inches, or the base is 12 inches, and then the height is this 10 inches right here. That's this length. So there's 10 inches right there. So if I wanted the area of one triangle, I'd do 10 times 12, but divided by 2. Base times height divided by 2 for a triangle. And that's going to give me 60 square inches. Of course, there is 2 of these. So in final, with both triangles, I end up with a surface area of 120 square inches. But we want the total surface area. So there's those 2 triangles, though, and it's good to have those out of the way. But then I've got this rectangle right here. Okay, so I'm looking at this rectangle right here, which I see the 15.6 inches right there. But this length right here, that's the depth of this thing. Oh, there it is, the 5 inches right there. So this area is going to be 15.6 times 5. Let's see what that gives us in the calculator. 15.6 times 5. And yeah, it doesn't duplicate, by the way. I get 78 square inches right there. So again, I'll underline that so I know that's one of the surface area values. Now, when I use this 12 right here, right, that was nice for the both triangles actually. But since they gave us the full length of this rectangle at the bottom, I can actually just kind of split this up, or not split it up rather, and just find it as a full rectangle. So as a full rectangle, it shows on the bottom 24 inches. And then of course the depth there is the height of that rectangle at 5 inches. So the area of that full rectangle would be 24 times 5. 24 times 5. So that'd be 120. square inches. And again, that's one of the surfaces. I'll underline that. So what do we got? 1, 2, 3, 4 more surfaces to go. All right, not too bad. I'll start with this front face right here. This one, which again, it does match this one on the back side as well. This one. And this rectangle is showing a base. We know it's a 12-inch. By the height of that, looks like it's 10 inches right there. So the area of one of these would be 10 times 12, which is 120 square inches. But I got 2 of those, which makes this 240 square inches. So there's 2 surfaces right there with this 240 in orange. And that's we did the bottom, the back. We got the top and the left then. Okay, no problem. So on the top, I'd be looking at this rectangle right here. So that rectangle shows it's 12 inches by 5 inches. So the area of this one would be 12 times 5, which is 60 square inches. Again, that's one of the surfaces right there. But I do have one more, and I've run out of colors. So I'm going to just do this one in black right here. So this rectangle in black, of course, it's got a 5 inches right there, but it's a height of 10 inches. So its area would be 5 times 10, which is 50 square inches. Boom, there we go. So we got, what is that, 6 different values, I think? Maybe 7. But we need to add all of those surfaces together. So, I'll start with the 50 in black that I got right there, the 120 in red, the 120 in green. We got the 60 in blue. Not doing these in any particular order. And then in blue we had the 60. I got a purple 78. And I got a orange at 240 right there. Hey, I just want to double check and make sure I didn't miss anything. 1, 2, 3, 4, 5, 6 values. 6 values. There we go. So we need to add all these together to figure out the total surface area. And I'll try to do this on my calculator, but I try not to jack it up this time. So 50 plus 120 plus 120 plus 60 plus 78 plus 240. I get 668. But again, this is in square inches on this one. See how fun this is? So now we got a sphere, or at least a half sphere. That's a hemisphere, by the way, on top of a cylinder. All right, so really what we have is we got a circle, we got a rectangle, which is the lateral area of the cylinder, and then we have a half sphere area. So there's only 3 areas on this one. That's not too bad. I'm going to start with the half sphere on this one. Remember, a full sphere, a full sphere, just like we saw with its formula, it was 4 pi, and then I'm going to show it as radius times radius. But since we're looking at a half sphere, we're going to need to divide that all by 2. And yes, they did give us the radius on this one at 5. So that would be 5 times 5 right there. Plugging this into the calculator, let's see what it gives us. Let's see, where r is the radius. It didn't say to round this. We'll say 2 decimal places, okay? So while we could write this in terms of pi, we're not going to worry about that. 4 pi times 5, all divided by 2. So it shows 50 pi, but again, I'm going to go for the decimal answer on this one at 157. And rounding to the nearest hundredth, I got 0.079, so I'm going to make it 0.08. Okay, so that's one of my surface areas right there. That's the half sphere. Now, before I do that rectangle, I'm going to do the circle right there. We'll do it in purple. And this circle, and it has a radius, once again, of 5 inches. So the area, and that's a full circle, by the way. The area of that circle is going to be pi times the radius, 5, times the radius, 5. So let's see what we get on this one. In my calculator, I get 78.539, so we'll make that 0.54. And there is the second surface on this one. So next up, we have this rectangle that wraps around both the circle and the half sphere. Okay? So to find this area of this rectangle now, we see it has a height of 20 inches. That's very nice. But we need the length of this thing, which is really the circumference of the circle. So we need to find the circumference of that circle, which would be 2 times the radius, which we know is 5, times pi. So what do we get? Typed it in incorrectly. I get 31.415, so I'll make, excuse me, we'll make that 42. That's the length of this rectangle right there. So if I want the area, I'm going to take 20 and multiply it by 31.42, which is 31.42 times 20, 628.4. And there is my third surface on this shape. Spheres are nice because it's just that one rectangle. Well, to find the total surface area, what I need to do is take these three values and add them together. So 157.08 plus 628.4 plus 78.54. And I get 864.02. But again, this is in area, so it's a square value in inches. We did it. All right, there we go. We're looking at a half sphere on top of a cone right there. That's very nice. All right, well, I would look at finding the lateral area of that cone first, probably. So, yeah, next time you get an ice cream cone, just, measure the radius of that and then figure out this is just surface area. It's not even volume, by the way. Now remember, and this one is nice. They gave us the surface area of the sphere. All right, I mean, we've seen it already. And remember, it's on a poster in the classroom, so hopefully that's not too bad. But I said I would start with the lateral area of our cone. And yeah, remember that we're not worried about the circle part of the cone, other than to find the radius for that sphere. So the lateral surface area for a cone, and I am looking at the poster, by the way, is pi times the the slant height, L, times the radius. So we do need the radius, which is just half that. That's a diameter it gave us, which means the radius is 1 inch right there. So I replace the radius there with 1 inch, or 1. And the slant height was given to us at 4 inches right here. So in my calculator, I will put pi times 4 times 1. And again, we'll round this to the nearest hundredth for this one. So it's a 12.566. So we'll make that 7 right there. Okay, so that's the lateral surface area of the cone. That's all that's on the surface for the cone. Next up, we have this half sphere, this hemisphere right here. So that would be, and again, we've shown the radius of 1 inch. So the surface area for a sphere, 4 times pi times radius, radius squared. But we're looking at half of a sphere, so we're going to divide that by 2. All right, and yeah, the radius we know is at 1 inch. So times 1 times 1. And this will tell us the full surface area of that half sphere. So 4 times pi times 1 divided by 2. I don't want 2 pi, but changing that into a decimal, I get 6.283, so I'll just make it 6.28. So adding these two together will give me the full surface area of this half sphere on top of a cone. 6.28 plus 12.57 in my calculator gives me 18.85. And again, this is in square inches. I do like my cones to be a little bit bigger than that, which is why I usually use bowls. All right, here we have 2 rectangular prisms that have been pushed together. We can see right there. So again, these are not on the surface. That little square right there, which is a square, we know it's because it's 2 inch by 2 inch square, a rectangle, which makes it a square. So since this is a square and it's not on the surface, we are not going to count that as part of the surface, total surface area of this thing, okay? So again, I would look at this as though it has 5 and 6, so 11 surfaces is what I would say this one has. You don't have to, but that's what I'm going to say it is, okay? And so it doesn't matter where you start in this. Again, just make sure you account for all the surfaces that you find on this, okay? So I'm going to start with this surface right here, which again, I know it matches this rectangle in the back, okay? And yes, it is a rectangle. It's very nice. Try to write smaller now so that I can fit all this. It's a 3-inch by 12-inch rectangle. So the area of this rectangle would be 3 times 12, which is 36. But I know I got 2 of those, so multiply that by 2, and I get 72 square inches. Again, I'm going to kind of highlight this one so I know that's one of my surfaces, or 2 surfaces, that I need to include in my final calculation. Now, on the next surface, I got this this purple rectangle right here. Okay, and in fact, it matches here on the back. But when I do this, if I do it this way, not that you have to, but I just know I need to subtract this square right there. Okay, so I can still multiply by 2, just subtract the square. So here's what we're going to do. I'm going to treat it as though it's a full rectangle. It's a width of 2 inches, but a height still of 12 inches there. So its area would be 12 times 2, which is 24. But again, I'm saying that there's 2 full of these rectangles, which would make 48. But then I need to subtract the square, and that is a 2-inch by 2-inch square. So that's 4 inches, which gives me a final surface area of 44 square inches. All right, again, we had to subtract that 4. That's the square that's not actually on the surface right there. So next up, I'm going to find the area of what is the top and bottom of this rectangular prism here on the left. And these are both 2 full rectangles. It's a 3-inch by 2-inch rectangle. So the area of one of them would be 3 times 2, which is 6 square inches, but there's 2 of those rectangles, so multiply by 2, and we get 12 square inches. Again, I'm going to highlight this so I don't lose track of it. Now that completes that one rectangular prism, which is very nice. But I can move on then to the next one. Well, I guess I'll start with the front face right here and the back one. They're the same. So this front face, again, has a rectangle. Looks like it's a 7-inch by 2-inch rectangle. So its area would be 7 times 2, which is 14. But again, there's 2 of these rectangles. So it ends up being 28 square inches total. But again, I'll highlight it, knowing that it's part of my final answer. And then, yeah, we got this green rectangle here on the right. I'm sorry, it's a square really, but a square is a type of rectangle. It's 2 by 2 square. And there's only one of these squares, right? So this area is going to be 2 times 2, which is 4 square inches. So that's going to be part of my surface. Just the one on the right, not the one on the left. But then I've got this rectangle on the top and this one on the bottom as well, which are the same rectangle. So this rectangle, it looks like, is 7 inches by, again, it's 2 inches again, which we've seen already. So that's 7 times 2, which is 14, but there's 2 of these rectangles. So I'll multiply the 14 by 2 to get 28 square inches. All right, let's add all these up now that we've figured out all the surfaces. Now, before I do that, I'm just going to double check to make sure I didn't miss anything. Yeah, it's okay to miss the square right there because it's not actually on the surface. I don't see any that I missed, although I'm not saying I didn't. But you got the 72 in red, the 44 in purple, the 12, the 28, the 4, and then the other 28. And yeah, we just need to add all these together. So what do we get? 72, that's 44, plus 12 plus 28 plus 4 plus another 28. I get 188. And again, this is in square inches because we are looking at surface area on this. Now, just so you understand, if you didn't want to subtract this square from this big rectangle right there that I made in purple, you could have found the height and width of that rectangle right there. What is that? 2 and 12. That's a 10 by 2 rectangle is what it looks like. But that's not the way we did it. All right, 2 rectangular prisms pushed together again. All right, find the area of this one. And yeah, on this one, let's zoom in on this. We can see that this shape right here is not actually on the surface. So we're not going to include this shape right there in our calculation. Okay. So it's going to work pretty much the same way as that last one. It's just now it's kind of a different rectangular prisms pushed together, right? So I can start with the small one. You can start with the big one if you'd like, but I want to get that small one out of the way because, I don't know, I just feel like it. So I'm going to start with the front face right here as a rectangle, right? This one shows something like this, which appears to be 2 feet by a height of 4 feet. Right here it looks like. So the area of this one rectangle is 4 times 2, which is 8. But again, it does have the matching one on the back side as well. So let's multiply the 8 by 2 to get 16. That's 16 square feet from those 2 red rectangles. But then we got this rectangle right up in here. And yeah, it matches there on the left as well, which is important to know. So this rectangle, though, is going to work just a little bit different. It's 1 foot by 4 foot. So its area, 4 times 1 is 4. But again, it matches it on the back side there. So we got 2 of them. 4 times 2 is 8. So that's 8 square feet. I should have highlighted those so I don't lose track of those. 16 and 8 so far. That's what we got. And then the top here we'll say is this. Almost looks like a square, but it's not. It's a 2 foot by 1 foot rectangle. So its area is going to be 2 times 1, which is 2. Now that is on the surface. I'm not multiplying it by 2 because the bottom one, which matches, is not actually on that surface. So that takes care of the smaller rectangular prism. Let's take care of the bigger one now. So in the front, I'll start with this front face rectangle. And I'll do it over here. And this rectangle is 16 feet by what appears to be 9 feet. So its area is 16 times 9. It's 90 and 54, so 144 square inches. But again, there's 2 of them, right? We got this one that matches it in the back. So I need to multiply the 144 by 2 to get 288 is what it looks like. And that is those 2 surface areas. And then I'll find this rectangle right here, which again, it does have a matching rectangle here on the left. And this rectangle is a 9 foot by 4 foot rectangle. So its area is 9 times 4, which is 36. But multiply it by 2, because there's 2 of those rectangles, which makes 72 square inches. And it's highlighted now, because I know that's one of my surfaces. And then in the top here, I'll have to do this one in black because I ran out of colors. But again, it does have a matching one here on the bottom as well. So this rectangle, and again, I'm finding it as a full rectangle, knowing that I'm going to have to subtract the area of this little rectangle right there, okay? So that's a 16 foot by 4 foot rectangle. So its area is 16 times 4, which is 64. But 2 of those makes 128 square units. But again, we need to subtract that this green rectangle right here, which is 2. So subtract 2, and the total surface area of the 2 rectangles minus that small rectangle. Thank you. Yeah, 128 minus 2 is 126. Now I will highlight it. There we go. But let's subtract these together to get our final answer. All right, the 2 red rectangles was 16. The 2 purple ones was 8. The one green one was 2. These are all in square feet, by the way. Then we did the 2 orange ones at 288. And then the blue, the 2 in blue was 72. And then the 2 black ones, but minus that small rectangle, is 126. So yeah, we just need to add all these together to figure out our final answer here. 16 plus 8 plus 2 plus 288 plus 72 plus 126. And I get 512. But again, this would be in square feet. I've been doing a lot of SQ feet, square feet like this. But remember, it is possible you can show it as feet squared as well. It means exactly the same thing. So I can find the surface area of composite figures. There's our objective.